Introduction to Clausen functions. So in this video, we are going to basically talk about the definition of Clausen function denoted by CL, m of theta, yeah, and some of its properties as well. So as you can see over here, the Clausen function with base m and argument theta is defined in two different ways. One when m is even, yeah, and other when m is odd. There are two definitions for two different cases. And when for m is even, it's defined as sum from k equals to 1 to infinity and sine of k theta by k to the power m. You might notice that this is somehow slightly similar to the Poill logarithm function as well. Yeah, you might notice that because Poill logarithm function was also x to the power n by n to the power p kind of thing. Yeah, and similar is the case over here, and this is just imaginary part of e to the power I k theta, yeah, it's so I can say that it's somehow similar these two. And now for if m is odd, this is defined as sum from k equals to 1 to infinity of cos of k theta by k to the power m. This is the definition of the Clausen functions. Now, what if for m even we want cosine, some of the cosine terms? So for to make that substitution, I mean to make that complete, we basically also define a counterpart of Clausen function denoted by SL m of theta, which is just the opposite. This is defined as sum from k equals to 1 to infinity of cos k theta by k to the power m is even, and sin k theta by k to the power m is odd, just the opposite of it. Yeah. Now these are the definition of Clausen function. Now some properties. Okay, if we have to talk about the properties, please notice that uh, CL2 theta is like Clausen integral function, and that's popular. And we let's talk about some of its properties. We know that CL2 of theta will, because this is even, we will go to the first definition. So it will be sine of k equals to, sorry, sum from k equals to 1 to infinity of sine of k theta by k square. Yeah. Now, if we take minus theta, we can clearly see that since this is a sine function which is odd, so CL2 of minus theta is going to be minus of this sum, so that's just minus CL2 of theta. Yes, and again, similarly, if we take CL2 of theta plus 2m pi, CL2 of theta plus 2m pi, this will also be just the sum from k equals to 1 to infinity of sine of k times theta will be theta plus 2m pi by k to the power 2. Yeah, now 2m pi times k, that will just be some integer multiple of 2 pi. So anything integer multiple of 2 pi plus some angle will just be sine of angle. So using that, we just get that this is equal to sum from k equals to 1 to infinity sine of k theta by k square, and that is just CL2 of theta. This is how we solve this. This is how we prove this statement. And these two are properties, or some simple properties of the Clausen integral function, also known as the L2 function. And this is the general definition of the Clausen function. In upcoming videos, we will discuss about more of its properties, its derivatives, its integral form, and reflection formula, and many other things. This was just some like brief intro about definition and some deep properties. Hope you enjoyed the video. Thanks for watching and look forward to seeing you in the upcoming videos too.